Hello again, everybody. Thank you for coming back for our afternoon session. My name is Christian Broderick from Stillwater Sciences, and I am going to be your host for the next 4 talks. And he's got the sign that says "End now," so I should be quick. Our first speaker is Melody Amar, who's going to be talking to us about Western Riverside County.
Okay. I don't know what that is. What is this? Hello, everybody. Oh, man, those lights are bright. I see we're at after the second break of the day lull. Thank you all for making it here. My name is Melody Amar. I am the Biological Monitoring Programs Manager for Santa Ana Watershed Association, which is a nonprofit organization originally set up to monitor the Santa Ana watershed for endangered species and habitat restoration through arundo removal. We continue to do this since 2000, and when the Western Riverside County MSHCP, Multiple Species Habitat Conservation Plan, was adopted in 2004, we took on their monitoring program as well. So let's see where, I don't know where buttons. There we go. First off, I really want to start with acknowledgements. Multiple agencies, collaborators, biologists in the field with all these different agencies that you can see up here help a lot with land access and sharing data. The folks, obviously Regional Conservation Authority, who oversees the MSHCP, funds the biological monitoring program in its entirety. But the field biologists, those are the important folks, the boots on the ground. They're out there covering hundreds of thousands of acres looking for lots of different species, which you'll see in a minute. And I want to point out that I think I've got a couple of them in the audience, Lucas and Nate, if you could just wave your hands. There's 2 of our rock stars, and I believe there's a couple other folks out here that used to be monitoring program biologists, so if any of you guys could wave your hands as well. We've probably had 50, 60, 75 over the years. So thank you all for what you do. So the Western Riverside MSHCP plan area is the hashtagged area. As you can see, it does not just include one watershed, Santa Ana or otherwise. There's several watersheds that covers a space of about 2,000, I believe. Yeah, 2,000 square miles, almost 1.26 million acres. It's a comprehensive plan with a lot of entities, multi-jurisdictional. This plan will eventually conserve 500,000 acres. And when it was adopted, it was set up with the cores, basically blocks of core areas and linkages. And you can see the darker green areas, and then the lighter shaded areas in orange are supposed to add to the core areas. So the darker green areas are cores that were already there and were brought into the MSHCP conservation area. And then all the lighter shades are areas where they intend to acquire new lands. And you can see all the different lines going through there and all those numbers. Those are all designated linkages or proposed linkages that are supposed to ideally link all the giant blocks of habitat together. At this point, there's about 433,000 acres that is conserved and well on their way to the 500,000 acres. Also in this area, as many of you that are local to the region know, there are a multitude of habitat vegetation communities. About a dozen are recognized in the plan, and they're all different color coded. The yellow is chaparral, so there's a lot of chaparral there. But it goes from montane to vernal pools, coastal sage scrub, meadows, just a lot of different habitat types. And those different habitat types hold a lot of different species. So the biological monitoring program has specific goals set forth in the HMMP that designates a biological monitoring program directly for monitoring the species of this HCP. And we're here to provide the data on which management can make their decisions to better conserve the species. Specific protocols were developed at the beginning of the monitoring program. Actually, the California Department of Fish and Wildlife were tasked with putting the monitoring program together, and that's when a lot of the protocols were developed. A lot of protocols were used as is that were already protocols for certain species, and others that were developed at the time when the collaboration peer-reviewed by a multitude of experts: CDFG Resource Assessment Program, USGS, Fish and Wildlife Service, Center for Conservation Biology, many of the universities as well. So we have a multitude of protocols. They set up an inventory baseline 1 through 5 years. That took about 8 to get that done. But right around that time is when SAWA took over the management of the biological monitoring program and employment. And now we're in basically our long-term monitoring phase. However, new acquisitions come in that are inventoried on a regular basis. So the monitoring program right now consists of a program administrator, data manager, GIS analyst, biologist supervisor. We have 4 taxa leads, one of which I had his hand up earlier. And we have 7 biologists, 2 of which are survey leads. So a relatively small amount of people to cover 500,000 acres monitoring. Oh, and I do need to mention the avian lead is a CDFW donated employee. Monitoring for 146 covered species. Yeah, that's a lot. A lot of them are plants, but still, very rare plants, but still, those can be some of the hardest ones to find. To my knowledge, the Western Riverside County MSHCP is the largest as far as areas conserved of an HCP, and this is the largest amount of covered species. So each one of these species has a conservation objective on what lands are supposed to be conserved for that individual species. Each species has occupancy objectives, where they're supposed to reside within the conservation area. And many of them also have species-specific objectives, which would include such things as evidence of reproduction, or 10,000 of these individual plants have to occur. It's in certain locations, things like that. So how did the people that put together the plan say they're going to have 500,000 acres and 146 covered species think that anybody could do this? They came up with some pretty good strategies for us to be able to be adaptive. We use multi-species, community-level efforts whenever possible. So riparian birds, for example, and I'll talk a little bit about that, but we do them every 3 years, and that covers 8 species, because 8 of them are riparian birds. We rely very heavily on incidental sightings for all of our focus surveys, and I'll show you the implication of that in a minute. We also are able to stagger the species-specific surveys over 3 to 8 years. So about 126 of the species have an 8-year interval, which means we really only have to survey for that particular species or find them at some point within an 8-year interval. And there are a few species, some of the more sensitive, some of the listed species that are 5-year, 3-year. And then we have 2 annual species, Kino checkerspot butterfly and Delhi Sands flower-loving fly, both listed and quite vulnerable in our area. So, as I mentioned, in 2023, we did riparian bird surveys. That was for 8 covered species. 5 of those species also, besides occupancy, required reproduction to be found, basically. And only 3 were occupancy only. So in 2023, and those are all done through riparian areas throughout the entire of Western Riverside County. So in 2003, the point counts, they met the objectives for 6 of the species. Now they're all over the place and they're out there all season. If the other 2 species were there, I'm sure they would have found them. Any of you that know birds in the area, yellow-billed cuckoo and southwestern willow flycatcher, very rarely seen these days. So what does a typical year look like? Last year, we covered focus species for 57 different species of those 146. We were able to detect 52 of those. 45 of those were incidentally observed. So that's really important, the incidental observations during other focus surveys, because we get a lot of information that way. And again, these biologists have to know cross-taxa. They can't just be birders. They can't just be mammalogists. They got to know all of the different species to look for. So since June of 2004, when the MSHCP was officially adopted, we have detected 142 of the 146 covered species in the conservation area. 30 seconds. I'm good. I think I have time for questions. Thank you. None. I love it.
One at a time.
Hello.
Can't see
You
out
said
there.
142 out of the 146. Do you know what the 4 species that you haven't found are?
Okay, I knew somebody was going to ask me that, and I
So
had it in
sorry,
my
I'm
notes,
so
and I
sorry.
didn't bring it. I will tell you for sure, San Bernardino flying squirrel is one of them. Red-legged frog was one of them until USGS did a translocation effort into Santa Rosa Plateau. And the others are plants. And if you ask me later, I'll get them for you.
Okay. Thank you so much.
But they basically pretty much we don't think occur. Some of the original observations, a lot of this data was from CNDDB way back then. Some of these species maybe were supposed to. Some of these observations of some of the plants were like 30, 80-year old. So some of them may not occur here any longer. Good. All right. Thanks.
All right, we get to go from Sawa to Sapa, and Ian's going to tell us about Arundo.
Hi, everyone. My name is Ian Ackamore. I work for the Santa Ana Watershed Project Authority, or SAPA. I'm going to be talking about 2 things today. First, provide a brief background on this plant, Arundo donax, known as giant reed, and its presence in the Santa Ana River watershed. And then the main topic, provide lessons learned on implementing this project, the Arundo donax removal in the Santa Ana River Basin Headwaters Project. So first, about the plant. It's a problematic plant, also known as giant reed, Arundo donax. It's invasive, non-native, and it provides no known habitat value. It can grow fast under ideal circumstances, 4 inches per day, and grow up to a total height of 33 feet. It's highly flammable, causes flooding by altering flow regimes, and it consumes a large volume of water. Estimates are that an acre of Arundo can consume up to 20 acre-feet a year per year. That's from the Cal IPC 2011 report. Arundo is a watershed-wide issue. A little bit of weirdness there in the middle. But it is a watershed-wide issue because its rhizomes can get uprooted and washed down in waterways. It's not known to spread via airborne seed distribution in the continental U.S., California. So it's really a watershed issue because it can wash down to different reaches. It's also important to tackle it quickly. It can spread quickly. And there are gaps in the area in the watershed because, as you've learned probably today, conservation can be done on an incremental basis depending on property management, mitigation funding at the time, and the presence of conservancies in the area. So SAPA is using, and I'm sure other agencies are too, but SAPA is using deep learning software to determine the presence of this plant in the watershed. We used some 2021 high-resolution imagery. We analyzed it with an Esri off-the-shelf product, a deep learning imagery analysis product. We saw that most Arundo, and this is the map of the results, analysis of 2021 imagery, where we detected 286 acres of Arundo. Most, as you can see in green, is upstream of Prado Dam. Prado Dam is that first black line on the border of Orange County and Riverside County. There's also a presence in Orange County, circled in blue, and it got us to reiterate internally, at least, that this is really a watershed issue, and so it makes sense to start at the top of the watershed. So we've been partnering with Inland Empire Resource Conservation District on this project that I mentioned, the Arundo Donax removal in the Santa Ana River Basin's Headwaters project. It's total budget of $150,000, and IERCD's tasks are to acquire property site access, survey for the plant, perform initial removal, follow-up removal, and follow-up maintenance and site checks of initially treated areas. Project area is the upper Santa Ana River watershed. I'll explain more of what that means. Revenue for this project is from the Santa Ana River Mitigation Bank, along a long-term bank partnership that we've had with Riverside County Parks and Open Space District. And the status of implementation. So this project began in July 2022. Our contract with IERCD expires in December 2027. And so far, about 10,000 acres have been surveyed, and 294 stands of Arundo have been removed to date. A little bit about IERCD, our partner on the project. They're one of 4 RCDs in the Santa Ana River watershed. Their service area covers the upper Santa Ana River watershed, making this a great partnership with them. Their related IERCD Arundo removal project have been focused on Mill Creek, Cajon Pass, amongst other projects. Those are just some examples. They have a detailed invasive species removal plan that their field staff implement, and they're certified by the Department of Pesticide Regulation for herbicide application when it's necessary. So the main takeaways from the project here, I've got 2 slides on this. To date, lessons learned, treatment method. So we've learned foliar treatment, where herbicide mixture is about 5% herbicide to 95% water, is sprayed on the plant's green leaves without cutting it, is faster, but is less effective in large stands. For those more substantial large stands, crews use chainsaws or heavy equipment to manually cut down the plants. The biomass is often hauled away, especially when working on private property, when private property is steep, and to avoid it being left on the property and regrowing. It only really takes one rhizome left over, or even a stalk left on the site, where the plant can re-sprout from even one of the nodes on the stalk. In terms of access, lessons learned, right of entry letter requests are very important. We're dealing with a very large area, and they've been refined and updated over time to increase participation by landowners. IERCD is really great working with landowners, private property owners. They have a real knack for that skill, and I'm sure a lot of you in this room do. And they've learned that, taking strategies like donating native plants that they've grown and giving them to landowners helps build a kind of partnership or in it together approach. And they've donated native plants after the initial removal is done to assist in building goodwill amongst the project, and also have neighbors talk to neighbors and spread the word about what we're trying to accomplish through this. In terms of planning, so when we started this back pre-2022, we didn't think there was as much Arundo in the upper watershed. We learned that there's quite a bit more than we initially thought. And also, I'm sure this is pretty evident to a lot of you, but working in the upper watershed, which I define as Riverside / San Bernardino County foothills / mountains, areas outside of the Santa Ana River main stem with perennial water, steep washes. That's kind of what I think of the upper watershed. It's really different in terms of Arundo removal up there. We have a lot of steep slopes, and there's lack of perennial surface water. Whereas in the lower watershed, Arundo stands can be far larger, as you saw from the imagery analysis, and there is more even terrain. So lastly, just the takeaways on next steps. As I mentioned, this is a watershed issue. Through this project, IERCD and SAPA, as you saw, are starting at the top of the watershed. But since Arundo can so grow so quickly and there are gaps in management across the watershed due to no one's fault, just because the nature of the business we're all in, the lack of funding, there's so many property owners across the region, there's a need to collaborate on a watershed level. So we're looking at doing that. SAPA is planning to form a work group to implement the following example task. Starting some meetings, and then the first part about bringing our meetings together is making sure we have the right people at the meetings. We have an initial group of interested entities we're going to invite, but we need to true that up by holding a series of collaboration meetings. Collect data on location, footprint, entity, and years of past and also current Arundo or related invasive plant treatment projects, basically gathering a list of projects that have been done pre and current, and develop a strategic plan that serves as a foundation for probably cost sharing Arundo removal going forward, especially in those gap areas that there hasn't been maybe any projects in the past, or there isn't a project planned in the near future. And thank you. Happy to answer any questions that anyone has. All right. Going once? Going twice? Anyone in the balcony? No? All right, thank you.
All right, our next speaker is Brandon Elrod, who's from the Disneyland Resort, and he's going to be telling us about how to make the happiest place on earth even happier.
Hello, everyone. It's very good to be with you. Thank you so much. My name is Brandon Elrod. I am the urban forester for the Disneyland Resort, and it's a role that I am relatively new in. I haven't been there super long, so I'm still learning all the systems and communication channels and everything. I come from a background in commercial arboriculture and horticulture, and have a background in chemical-free and two-cycle fuel-free landscape maintenance. So that's the vantage point that I come into this forester role with. And it's very humbling to be in your presence today. It's my first time attending the Santa Ana River Science Symposium, and it's really inspiring to see all the conservation effort and the thoughtfulness and care that everyone here is representing and putting into this effort. And this ties into something that is a very core belief for me, which is if you are collectively representing agencies and municipalities and government and all these big efforts, then what is the citizenship doing to join in, to be part of it? And this is something that I'm passionate about, and I'm hoping to see this flourish and cultivate in all the ancillary landowners that line the Santa Ana River. The Disneyland Resort is 2 miles off the river. So on the one hand, that seems really, really far away. On the other hand, it seems extremely close. And so that's an interesting balance to hold as far as perspectives. And it's very easy to take a very, out of sight, out of mind, that's so far away approach, but I like to take the bigger picture approach personally. And so part of our initiative at Disneyland is to take a much more assertive and thought leadership position moving forward when it comes to how we treat our urban forest. And so what I'm going to be sharing today is the result of a 2-year trial that we have been experimenting off-site in some of our remote parking lots that I'm sure some of us in here have parked and made the trek from. And putting to the test tree species that could be more helpful allies in the quest for water stewardship. I really, really appreciated the quote from Secretary Wade Crowfoot earlier. He asked the question, how do we manage landscape to ensure our communities have the water they need? And I think that's a very thoughtful and poignant question. If we all remember back a few years to the state water mandates, when there were restrictions and number of days per week and all that, one of the unintended consequences was the decline and death of a lot of trees. And whether that wasn't really factored into the decision or not, it brought a lot of awareness to impending water stewardship. And from a private landowner perspective, this question of how can we be good stewards and good citizens in this process. So this trial that we did, we called it the Climate Ready Tree Project. And a climate ready tree is a series of, it's about 30 species that were suggested by a few different researchers, David Teschler, Dr. Matt Ritter, and David Muffley in the tree care industry. And they suggested these as potential options for climate resilient tree species that could supersede even the resilience of our native species. And that is a really, really significant thing because for a long time, from a conservation perspective, we've aimed at our native tree species as the end all, but when it came to those water mandates, those state mandates a few years back, we saw those trees even declining. So what are the options for the future beyond our native tree resilience? So this is what we looked at. Climate ready tree is a tree species with the potential to be more adaptable to the hotter, drier climate that is predicted in Southern California and the reduced quantity and quality of available water for landscape use that will follow in regards to switching to reclaimed or any of the other options coming up. A climate ready tree will tolerate aridity, increasing temperatures, soil incompatibility, and water unavailability. So our project scope was to plant 285 of these trees. They were all fairly large size when they went in. They were 36-inch box, which is probably about a 12-foot height, planted height on average, representing these 30 species that were recommended. And the intent of this project was that the winners, so to speak, the best performing trees out of this batch would be incorporated into our long-term strategic plan that we are nearing the completion of developing, which is our urban forest and landscape master plan. So these would be an integral part of future vision for sustainability and regenerative practices. This is a list of the trees that were included in the trial. You'll notice most of these trees come from two genera. One is eucalyptus, and the other is quercus on the right side. Quercus being our oak species, eucalyptus being our gum species. And the eucalypts are primarily, of course, from regions like Tasmania, Australia, and so on. The oaks included in this trial ranged from California natives, just not Southern California per se. Channel Island, all the way over to Texas, was kind of the range of oak woodland that these species were selected from. And then we have a handful smattering of other species as well. A notable one being a platanus, that's a sycamore alternate that is known as the Roberts cultivar. And that's an interesting one because sycamores were hit very hard in the water cutbacks when combined with the pest outbreaks that they suffered, because water stress always predisposes a tree to other environmental factors and pest infestation. So, installation, we put these trees through the ringer, I gotta tell you. We picked the worst soil possible. You guys are ecosystem and ecological experts. We took destroyed native habitat. We took destroyed soil. It was, it's construction grade, 95% compaction, turned, scraped. It's just sterile growing media. We had to use power equipment to drill planting holes to give you an idea of how hard the soil was, and we broke 3 of the power heads on that tractor. So this was real world trial, because that is what commercially here in Orange County we are dealing with in master plan communities, commercial properties. That is the quality of the soil. Heavy, heavy compacted sterile clay. So we dug our planting pits wider than the tree root ball, at the same depth of the root ball, and installed a little drain for water to not pool in there. Watering, we were also very judicious with. Now, as has already been mentioned a few times, wet winters the last 2 years. So, during those rainy months, trees were getting really the ideal amount of water that they should be getting. Even if they were irrigated, that's 20, 30 gallons per watering is ideally what they would be receiving. We just dripped little essence of water, whispers of water on them, and we gave them on average 3 gallons of water per week. And in that small size where their trunk caliper is about 2 inches. And about 18 inches into the trial, some of the trees were really stressing, and we'll talk about the performance, but we bumped the water up to 5 gallons a week. But really, that was kind of the max that we contributed, because we're really trying to hone which of these tree species will be a good fit for moving forward, so we can use less water in stewarding our natural resources. So here's what it comes down to. Here's the top 10 performing species. In the photo, we have that sycamore alternate, that Robert sycamore, has been performing very, very well, and it's gorgeous. The leaves are just massive, really huge, dark green up top, a really great candidate. But here's our top 10. We had number 1 performing when it comes to dryness, heat, and these are in parking lots, so you're getting that heat island effect, a lot of radiant heat, and then terrible soil conditions. So number 1 was cider gum, then a Chizos red oak, I believe that's from Texas, Mexico area. Then that Robert's western sycamore that's pictured, Mexican blue oak, orange gum, a pistache, if you're needing some fall color, this is one of the options. Sky climber, southern live oak, silverleaf oak, Sierra oak, and Amio gum. So that was the top 10 of the 30. We went on further to even to parse the list out even more at a more granular level, to factor things like how finicky is this tree, how pest prone is this tree, what's the structure of this tree like? Is it wonky, or does it have a really great structure to work with? How much do we have to fiddle with it? How well does it rebound from flooding from all the extra rain that we had? And so on and so forth. So we have further rankings, but this was just the kind of the climate resilient effect and results. So very pleased with the trial. We saw which trees failed and which ones succeeded. And so these are trees that we are going to be using as options into our future planting efforts throughout the resort. And that's the result of our study. Thank you very much. We have a couple questions.
Thank you so much. When I was employed at the city of Anaheim, we worked so closely with Disney on so many projects, including trees. And this is a great opportunity. I know there's a lot of folks here from UCR and from the academia, and of course all the conservancies. But this is a great opportunity to work with the private sector also. Have you published these results? Is this information available to the public?
This meeting is actually the very first initial release that I was given to be able to start sharing these results, but a paper is intended to be coming in and published. So, yeah, good suggestion, Pamela. Thank you.
I think I'm next.
Okay.
I can think of other conservation targets when setting up a study like this in addition to how much water is being used. For example, fire resilience, invasibility, habitat, food resources for wildlife, thinking of urban environments, as in support of bird life. Flammability of, what's falling on the ground. Were any of those sorts of other, and potentially more, conservation targets thought of when setting up the study to begin with?
That's a great question. I don't think it's an official certification, but trained in wildlife, tree care for wildlife. And so that is definitely a priority and value. So that's a factor. And as far as some of the invasiveness, that was part of the selection process, but there was also the real world reality of having very little that would grow in that soil. Based on its compaction and degradation, that there was little thought put into the invasive quality because we were just trying to get anything to grow in the first place. But
And just
good questions.
quickly, I would assume that this information would not transfer to, for example, Riverside, California.
I know that there are other landowners that are also doing trials with the same batch of trees for use in a very, much more public setting, a much more corporate kind of office park kind of setting. So those results should be coming out as well.
Thanks so much for sharing. I'm just curious, we can talk offline, if Disney would be interested in doing a pilot with some botanists that are also working in the Santa Ana watershed on just a focused, native habitat piece, like a showcase, in the Winnie the Pooh land or Rise of the Resistance, only because you're so good at educating and you're right there in the watershed, and there's a lot of great science here where I'm sure we could help you with, if, grant funding or anything to do something like that.
That's a great idea. I'd love to talk more offline.
Okay,
Thank you
there
so
we go.
much. Thank you, everybody.
All right. Hopefully the trees are resistant to lightsabers or whatever happens there. Our next speaker is going to be Cam Murray, who's going to be speaking about San Timoteo Creek.
All right, good afternoon, everyone. My name is Cam Murray. I'm a biologist at DUDAC, presenting to you today on the San Timoteo Creek Habitat Monitoring Plan. I'll be doing the presenting today, but I'm actually joined by both Jennifer Ayers, the Water Resources Manager from Yucaipa Valley Water District, and my colleague from DUDAC, hydrogeologist Steve Stewart. So, quickly, try to cover things relatively straightforward. Just have 10 minutes, which is not a lot of time. All right, let's start with the map. I imagine everybody knows what we're looking at. The black outlines the watershed boundary. The darker blue bold line, that is San Timoteo Creek. It's about 30 miles from top to bottom, covers a watershed of about 120 square miles. The lightly shaded area there is the sphere of influence for the Yucaipa Valley Water District. All right, we'll jump straight to it. So why are we monitoring for habitat in San Timoteo Creek? Back in the 2000s, early 2000s, the district was looking at ways to increase recycled water use among its customers. What that means for the creek is that the existing discharge to the creek, shown by that yellow line that extends south, basically less water would be put into the creek. Normally, recycled water use is a good thing, but in this context, putting less water in the creek begs the question, what happens to what's there now? So the creek supports a rich riparian ecosystem, lots of willow riparian habitat, lots of sensitive species, and in particular, the federally endangered least Bell's vireo. So this is an overview of the HMP, the monitoring program. That second yellow line that extends just directly to the west was a second or an alternate discharge pipeline that was put in by the district, anticipating the need to discharge water at a second location if that need ever arose. But I'll walk you through that red shape on the edge there. That's the district's treatment plant. Monitoring Station 1, the HMP was set up to have an upstream control site and 2 downstream treatment sites, or sites where we monitor potential effects. The upstream site is on State Park's property. It's just under a mile upstream of the outfall location. Monitoring Stations 2 and 3 are the downstream locations, both on private property. Monitoring Station 4 didn't come online until recently when that parcel by the outfall was acquired by RCTC. So the main point from this to get is that basically the study area for the HMP extends from the outfall all the way downstream to Alessandro Road, but that entire stretch of land or stretch of creek is privately owned land. And so this wasn't a situation where we could go in and do our GIS and say exactly where should we put our monitoring sites. It was a kind of a matter of who Jennifer could convince to let the district onto their property. So that's where we ended up with sites 2 and 3 downstream. All right, just briefly, this is one way to look at a timeline of the HMP. The blue bubbles and lines is the discharge, the average discharge from the district's outfall starting in 2001. You see over time it's pretty steady until we get to about 2014, and that's when the district actually started reducing their discharge. What happens, and it is predictable, but recycled water demand by customers is highest in the summer, so discharge to the creek is lowest in the summer. So when you see the lows, that's summer, the highs are the winter. A couple milestones from the HMP. We originally did mapping in the creek, habitat mapping in 2002. We prepared the HMP in 2005. We didn't get to implementing the HMP until around 2011. A year after that, we actually got the permanent groundwater wells into the ground to also monitor groundwater alongside the habitat monitoring. And then a couple of years later, discharge reductions began, and then we have a few other things that happened. Shot hole bore became a big topic in 2016 around then, so the district started implementing bottle trapping at their sites. District also installed some well clusters. Steve could tell you all the detail you want to know about that, but basically what that lets us do is look at the vertical hydraulic gradient, whether water is flowing up from groundwater to the creek, surface water, or surface water down. And then a series of natural events. One, the Palmer Fire in San Mateo Canyon took out 2 of our monitoring sites. And then from a series of floods from high winter events, we lost a couple monitoring wells. 5 minutes. Okay, I got to speed up. Just for context, we start our journey with the HMP in 2011, and you can see this is just cumulative departure from mean. So just giving you an idea that this period of time that we're looking at habitat in the creek and we're trying to look at the effects of water or the discharge from the district's outfall happens against a backdrop of rainfall where in general we're seeing more consecutive months of below average rainfall than above average rainfall. Really quickly, the habitat monitoring consists of on the ground, we do spring visits, it's a qualitative visits, we do permanent photo monitoring stations, and then in the fall we do your run-of-the-mill point intercept transects through the habitat. We also do a desktop GIS exercise where we quantify the acreage of riparian vegetation in the study area every year, and then we are generously granted the use of SAWA's video data every year. So. In terms of adaptive management, the threshold that we're kind of looking for is to compare upstream conditions to downstream, and anytime there's a difference of greater than 10% between upstream and downstream in terms of riparian vegetation cover, that would trigger management, which means the district has to put more water into the creek. This gives you just a picture of what it looks like on the ground. That grid over there are our transects. This is the upstream site, monitoring station 1. The pink dots are Vireo locations, but this is 2018 data. One of the themes of this monitoring program, or one of our experiences, is that things are always variable. As time went on, SAWA had less and less access to private property on the creek, so at some point, these areas were no longer in the area that could be surveyed by SAWA. So That's 2018 data. You see OW4A and 4B are cluster wells. OW1P, that's a permanent monitoring well, tells us groundwater elevations. And then just a point showing a shot hole bore bottle trap. This is just zoomed in a little bit more. You can see the relation of the permanent monitoring wells. Actually, these haven't been installed. If there's anybody from CDFW doing permitting, we have our permits. We haven't put them in the ground yet. But anyway, the green points are the photo monitoring stations. All right, so results. Oh boy, 2 minutes. Okay, I'll do this really quickly. The first couple of years before discharge changes. It was actually a period of drought, but in terms of what we saw in the vegetation cover, it's a pretty steady course of years. In 2015, there's a precipitous drop, or kind of a concerning drop, but what we see is the same effect upstream and downstream. So thankfully, we do have an upstream monitoring site, and with some degree of confidence, we can say it's probably not related to the district's discharge, or when they started declining, reducing their discharge. 2017 is the Palmer Fire, took out 2 of our sites. The red line is the upstream site on State Parks land, eventually recovered, or is in the process of recovering. The black line is the monitoring station 2 on private lands that ended up being cleared after it got burned by an adjacent property owner, took out our equipment, took out all the habitat, so we just bailed and said, we'll find another place to go if we can. This is, I'm going to skip over, but basically when we actually want to look at the threshold, we put confidence intervals on our annual change, compare them and say, is this something we really need to be concerned about? For the most part, with the power that we have from the data, a lot of times there's not a distinguishable change from previous years or not a distinguishable change from upstream and downstream conditions. Want to get to this. This is what the groundwater monitoring wells look like. This is a pair of them. Our management threshold when it comes to groundwater is to keep the shallow groundwater above 10 feet below land surface. If we decline below that, then it means increasing discharge until we get back up to that point. This is what the groundwater data looks like. We've got green, which is the district's discharge. Again, you see it's steady, and then it starts to bobble up and down. The purple is cumulative rainfall, just for context. Blue and black are downstream, and red is upstream. It's hard to see, I get it, but one thing we can do is just focus on one area here. And this is kind of really the crux of it. At the outset, I think, at least I know, I kind of imagined that 3.5 MGD of discharge into the creek, you're going to reduce it, say, by 1 million MGD. That's probably going to have some big impact. But in actuality, what we saw is very little effect from changes in discharge. One thing you can look at, maybe October 15 for the next couple months, you see almost a 1 MGD increase in discharge to the creek. But if you look at the blue and the black lines, there's very little change there. So the big message is the big bumps happen from precipitation. So it seems that the effect of runoff from the watershed is really the driving factor here. Really quickly, the lessons. The influence of the discharge, we don't say it's not there, but it looks to be much shorter in distance downstream than we had originally anticipated. There are way bigger factors at play here than the district's discharge to the creek. We've got runoff, we've got stream flow from other contributors upstream. And what we discovered is that some portions of the creek are actually gaining systems. So instead of surface water draining to groundwater is contributing to surface flow in the creek. The last thing, again, same theme, is that discharge has much less of an impact on the system than we originally anticipated. And now we've got about 10 years or so of data to kind of back up that fact. Last one, just a couple pictures. Lots of issues to deal with over time. That tractor probably is similar to what was used to bulldoze one of our monitoring sites by the adjacent property owner. Just the adventures you encounter when you're trying to do monitoring in the real world. Anyway, looks like I'm past time. Yeah. All right. I'll take any questions, and Steve and Jennifer are here too if you have any questions that they might be able to answer. All right. The pigs are still there, yeah. I didn't, oh, there it is, yeah. I thought I was going to do a picture of the pigs, but yeah, the pigs are still there, for sure. And I think the story is they get fed. They're sort of supported artificially to be there because some people like to go in there and hunt them, so.
Hi, thank you. I just want to say this is my neck of the woods, so I'm really interested. I know this study particularly was water quantity. You were looking more at like stream flow, base flow, all that stuff. Do you guys have any numbers on actual quality, like quality metrics and stuff, as far as looking at the upstream versus downstream? I'm just really curious. I've done a lot of conservation work and stuff in the area, and I was just kind of wondering how that's affected water quality itself. Thank you.
Thank you. Jennifer's nodding her head, but, so I think that means yes.
Perfect.
Do you want to, come on up, Jennifer.
Hello, Jennifer Ayers, Ukaipa Water District. I don't know where the question was. Oh,
Thank you.
hello. Yes, 10 minutes is very quick to discuss all the dynamics that go on here. But one of the requirements we also have, not only with discharge, being a discharger into the Santa Ana watershed, is the max benefit program. So we do monitor water quality. Twice a month, we do creek sampling. It does help with this program, but it also helps with the basin monitoring program at max benefit. So we have all the water quality data as far as like TDS, nitrates, anything else, Steve, we want to add to that? General chemistry. So that's a report that goes to the regional board, I believe, by April 15th every year for water quality.
Thank you. I'm just curious because it's so urbanized upstream from you guys. You've got the
Yes.
whole Calamasa developing and all kinds of construction going on. I'm just wondering if there's been any kind of change in quality. Just me being a nerd.
I probably can get back to you on that. I'm not sure about the trends. We, as far as our water quality, our limits are good, but we are doing programs to kind of see what those upstream influences are, to kind of get more of a holistic approach, working with Beaumont. They're discharging into the creek as well by Cooper's Creek, which eventually flows to our area. So we're tracking that.
Awesome. Thank you.
Thank you.
Thank you.
Okay, we're set for a break now. We're going to come back promptly at 3:30. We're running one talk behind. So Mia will be giving a talk next, and we'll see you in about 20 minutes.